G'day, welcome to Year 7 Mathematics. How you going? Cat always trying to take over the world. Alright, welcome to Simplifying Ratios. So today for Year 7 Maths, we're going to go through, again, mostly the core content. I have some extra stuff if you want to, but we might leave that to Thursday. We'll see how we're going. Alright, so simplifying ratios. So the same as fractions. If you have some ratio, you need to simplify it. So if all of a sudden you had 8 to 24, you need to put that in its simplest form possible. As it is, it means 8 parts to 24 parts. I don't know what that could be. It could be, I don't know, strawberries to ice cream or something. Either way, to me, I can see straight away that's saying there's 3 times as much ice cream as strawberries, but I don't know about you. So the same process as if we had 8 over 24 as a fraction. We would try and find the highest common factor. Remember highest common factor? HCF. Highest common factor. I hope that red looks all right there. To find, basically it's the biggest number that goes into both parts, or all parts rather, because we can have ratios with more than 2 parts, as we showed in the last video. So in this case, you're going to look at it and go, well, the biggest thing that goes into both of them is 8. So the HCF is 8. I divide both sides by 8. I get 1 to 3. Process would have been exactly the same with our fraction over here. Divide both the top and bottom by 8, you would have got 1/3. Alright, so we do a more interesting example than that. We'll do 14 to 77. Clearly they gradually get harder in terms of working out the highest common factor. What's the biggest number that goes into both of them? A little bit of an unusual one. 14 doesn't go into 77, it's not 14, but 7 will. So in this case, the highest common factor is 7. We divide both by 7, we'll get 2 to 11. Now, I'm going to introduce a little bit of a complication now. In the previous lesson, I noted that ratios did not have units and they were always in whole numbers. So we're going to play in the space of, hang on, what if they don't come in whole numbers? That's after this brief break. And we're back already. So, the 2 situations we're going to look at here, a little bit of reflection, is that better? All right, the 2 things we're going to look at now is, well, what happens if you have a fraction or a decimal in a ratio? We need to change it to be whole numbers. So what are we going to do? There's something with fifths, something with seconds, halves. Any ideas? All right, I'll give it to you. It's the same as what we do for addition and subtraction of fractions, and that is, first off, we want the same denominator. So essentially, the trick here is change to the same denominator in a simple case like that one. So how do we make sure they have the same denominator? Same way we deal with fractions normally when we're adding and subtracting them, and that is we find the lowest common multiple. We want the first multiple that's in common for 5 and 2, and that's indeed 10. If I started listing multiples of 5, I'd go 5, 10, 15, 20. Multiples of 2, 2, 4, 6, 8, and so on. It's 10. So first off, I'm going to make them have the same denominator. So for this one, I'm going to multiply by 2, top and bottom. Remember that makes an equivalent fraction. That fraction eating 3 pieces out of 5 of a pie is the same as eating 6 pieces out of 10. And here, to make the 1/2 out of 10, I'll multiply it by 5. We get 5 out of 10. Again, exactly the same as a half. Now we can compare them. The beauty is right now, once we're dealing in the same denominator, we can actually just drop the denominator. It's 6 parts to 5. We could draw a picture of a pie and, well, it's in proportion still. So 6 to 5 is actually what that ratio will be. If you ate 6 pieces versus 5 pieces, it's still the same proportion as if you ate 6 entire pies versus 5 entire pies. It'd still be eating 20% more if I wanted to be really fancy about it. But that's for another discussion. Now, let's look at something nasty like this. Now, this comes back to that philosophical issue I've been talking to you a bit lately about when you see this thing, and obviously it's meant to be a mixed fraction. It's meant to be 2 plus 2/3 there. And we're gradually going to be moving away from these mixed fractions and leaving things as improper generally. But here is one of those horrible mixed fractions again. What's it doing here? Right, so if you are presented with fractions that are in the improper form here, I'm going to give another tip. Convert to improper first. Now, we've looked at some of the quick ways of doing that. 2 lots of 3 out of 3. So 1 is equal to 3/3. 2 will be 6/3. 2 times 3 gives us 6/3. Plus another 2/3. That's the same as 8/3. And over here, 1 is the same as 4/4. Remember how we can multiply the 1 and the 4. And there's another 4th up there. So I've got 5/4. Now we've merely got something that's in the same step as up there. So what do you think I'm going to do next? Need to have the same denominator, right? So lowest common multiple of 3 and 4. It's going to be 12 if you're counting 3s and counting 4s. So I'm going to change them to be over 12. That's got to be multiplied by 4, top and bottom. So that's 32 over 12. And this one here, top and bottom has to be multiplied by 3. So I'm going to get 15 over 12. So it's 32 parts to 15 parts. We don't need to divide by 12. It's still 32 parts to 15 parts. Now, the other thing that we haven't dealt with here is the need to simplify. At the moment, I don't think they can be simplified any further, can they? Well, 6 to 5 definitely can't be. Is there anything common there? I don't think so. 3 doesn't go into 32. So this can't be simplified. If it could be further simplified, then of course we'd need to do that. So that's fractions, guys. All you've got to do is, if you've got mixed fractions, make them improper. No matter what, you then need to get them to have the same denominator, find the lowest, get them to the same denominator using lowest common multiple, and then you can get rid of that denominator and you've got your ratio and whole numbers the way we want it. All right, so here, this one's got decimals in it. So we're not allowed to have fractions in ratios and we're not allowed to have decimals. This one I think is a little bit easier, but it's not in your text. It's not covered at all. So I thought, let's show you anyway. How can I make this so that these are all whole numbers? I bet a few of you are already going to guess what I'm going to do here. I'm just going to multiply both sides by 10, right? Because if I multiply both sides by 10, there won't be any decimal places anymore, and will there? So I'd get 14 to 26. Do they have anything in common? Can I simplify them? Pretty clear they will be able to be simplified because both of them are even numbers. So I'm going to divide both sides by 2. If they're both even, they're both divisible by 2. That's going to give me 7 to 13. Pretty sure that's going nowhere because they're both prime numbers. Do you remember what prime numbers are? Anyway, the trick with converting decimals overall is to multiply by a power of 10. In the situation we did there, it was just 10. But in other cases, it might be 100 or 1,000 or even 10,000 or similar if we wanted to go crazy, right? Speaking of which, this one's a lot more ridiculous. How would I get rid of the decimal in this situation? Well, that one there only needs to be multiplied by 10 and you'll get rid of the decimal. But here, if I multiply by 10, I'll still have a decimal. If I multiply by 100, I'll still have a decimal. I'm going to have to multiply both sides by 1,000. So let's do that. Let's multiply both sides by 1,000. We're going to get 1,344 to 548. So 1.33344 parts to 54.8 parts is the same as writing, whoa, you didn't see that. Same as writing 1,344 parts to 54,800. Notice, do multiply by 1,000 correctly. That will really cause you issues if you don't. And, you know, that looks rather ridiculous to simplify. So I reckon we should try the calculator trick on this one. Put it in as a fraction, press equals, and let it do the simplify for us. You will never have to do a simplify like that without a calculator and a test, okay? That's just nasty. We're mean, but we're not nasty as maths teachers, okay? So, yes, if I had something ridiculous like that ratio there, I'd shove it in my calculator to simplify, and I welcome you to as well. So it's giving me 84 parts to 3,425. Now, if you did do that by hand, then, you know, kudos to you and everything. I'm not even sure what number it's dividing. Oh, well, you know, I can find out here how would I find out what it's been divided by there? I can simply go that number divided by that number. So I'm going to do 1,344 divided by 84. Oh, there you go. It worked out that 16 was the highest common factor between those two and divided both sides by 16, you know, as you do. All right, so there's the story, guys. Fraction, make it improper if needed, get the same denominator, cut off the denominator, and then simplify if you have to. Decimals, multiply by a power of 10, so by 10 or 100 or 1,000, so on, then simplify your answer. And that's as far as that goes. So I'm now going to go into a couple of other areas we need to demo in just a moment. And we're back. So now we're going to go on to another area, which is, we discussed ratios had to be in whole numbers, and we just looked at a whole heap of issues if ratios don't have the same numbers. But ratios also don't have units. So to make a ratio, when you're trying to compare things in different units, you need to make them the same units first. And this causes a surprising amount of grief among students because a lot of students aren't so confident in changing between different units. So, but you guys are probably going to be pretty good. So let's see how we go here. So the first two examples are pretty standard sort of examples that you'll find in the Year 8 text. And then I've got a couple of nasty ones on the end. So I'm pretty nervous about the nasty ones because if I get it wrong, I have to restart the video. You just don't want to go there. All right, so first question, 8 millimeters to 4 centimeters. What units should I make these in so that they're in the same units? As a general rule, it's easier to go to the smaller unit, which in this case is millimeters. It's easier to go to the smaller unit because think about it. If I went to centimeters right now, I'd end up with a decimal. And we can't have decimals in ratios either. So I'm going to cause myself more problems if I go to the bigger unit. So generally, I'm going to recommend we go to the smaller unit. We'll follow through here. With this minutes and hours thing, the smaller unit's minutes. With centimeters to kilometers, the smaller unit centimeters. With seconds to days, the smaller unit seconds. I'm going to use that approach throughout because I think it's a bit easier. Either way, if I want both of these now in millimeters, 4 centimeters, what's that in millimeters? I'm hoping you know to multiply by 10. I'm going to get 8 millimeters to 40 millimeters. At this point, since you're comparing apples with apples, you can actually get rid of the units entirely. So it's 8 parts to 40. Now, there's one issue with that, and that is it can be simplified. So what's the biggest number that goes into both? It's 8. And so the ratio will be simplified 1 to 5. So 8 millimeters to 4 centimeters, if you think about that, 8 millimeters is about that, 4 centimeters is about that, is in a 1 to 5 relationship. That's 5 times as big as that. Now we're going to do the same with some trickier ones. 20 minutes to 3 hours. I wonder what that is. That's some sort of, I have no idea. But anyway, so we need the same units. One's in minutes, one's in hours. How many minutes are in an hour? Hopefully you know that's 60. So to convert that into minutes, I'm going to multiply by 60. And we're going to get 20 to 180. Again, oh, I almost skipped there. I instantly wrote it as 20 to 80, which it is. But I'll just show you the working. It's 20 minutes to 180 minutes, where we therefore don't need the units anymore. It's 20 to 180. Biggest thing that goes into both sides, a bit of a giveaway this time. It's 20. So we've got a ratio of 1 to 9. Which makes sense when I think about it, because there's 9 lots of 20 minutes in 3 hours, isn't there? So that's all right. That makes sense to me. We can always do a check on the sanity of the answer. This is nasty. That's why I've left so much room. I'm trying to get 50 kilometers into centimeters. Well, let's take it step by step. First off, I would turn the kilometers into meters, right? There's 1,000 meters in a kilometer. So that's the same as writing 20 centimeters to 50,000 meters. And then to get meters into centimeters, I need to multiply by another 100 to get into the same units. So at that point, it'll be 20 centimeters to, we need 2 more zeros there. So what's that going to give us? 5 million. There are 4 zeros there. There's 6 zeros there. That's definitely right. And that means I don't need the units anymore. The highest common factor there is definitely going to be 20. That's definitely going to be able to be divided by 20. How confident are you in doing that in your head? Look, what I'd do is I'd knock the zeros off there, because that divides it by 10, which means I only need to divide that by 2. I need half of that number now. So half of 500,000 is 250,000. So that's actually not as bad as we might have imagined, simplifying that without a calculator. It's doable. This one here, well, we're going to find out. So 5 seconds to 2 days. Well, days we'd first need to convert to hours. We'll go 1 unit at a time. So that's 5 seconds to 48 days. Then if we wanted the days in hours, hours, I'm already in hours. To convert it to minutes, I'd have to multiply by 60. So 5 seconds is then equivalent to, what's 48 times 60? 388, is it? 3880 minutes. I'm going to check that quickly, because you know what? That's big number. No, see? I made a mistake. 2880. I am tired, sorry. I do make a mistake every year or two. It's just part of the game. Now, from there, I still need it into seconds. Notice how I'm moving 1 unit at a time. I've gone from days to hours to minutes to seconds, right? That's the process. You could use other ways of doing this, but that way I find very reliable. So now to get it into seconds, I'd have to multiply by 60 again, because there's 60 seconds in a minute. I'm going to do that on the calculator, sorry. And I get a huge answer, 172,800. And now, at least, they're in the same units. So it's 5 to 172,800. That number's definitely going to be divisible by 5. You should be able to tell me why. It ends in a 0. So if I divide both sides by 5, the ratio here is 1 to 34,560. Now, obviously, these two are very A, B level examples. They're right at the top. Do not fret. Most of your practice will not be like that. I'll be back in a moment. And we're back again. The last bits I'm going to leave you with today, because I don't want this video to be too long, is an optional activity here. I was looking for sugar content in soft drinks, and I found, well, I think it's some lobby group, but the data looks interesting anyway. It's www.rethinksugarydrink.org.au. Pretty sure that's what I was looking at. And there was this page on it called How Much Sugar, with dashes in it. Anyway, there's some data on there. If you'd like some practice with ratios involving decimals, it's a nice little data table. So tell me, what measure is the best to compare the drinks? I want you to think about that. Then once you've done that, I want the ratio of sugar between Solo to Gatorade Tropical, Sprite to Coca-Cola, Fanta to Lipton Iced Tea, and Solo to V Energy Drink to Powerade Lemon Lime. So a 3-part ratio. Recommended exercises for today, please do. Year 8 text exercise 6B. I want you to have a go at 6, 7, 8, 9, 11, 13, 15 and 17. So good luck everyone. I'm sure you'll be all right, but if you've got any problems, just send me an email, ask a question. I'll get back to you as soon as I can. See ya.